You may have watched a previous video in which we looked at how to work out the area under a graph, but in that we didn't discuss why you would want to do that. So that's the purpose of this video. Why would you want to work out the area under a graph, under a curve? I actually want us to go back to something perhaps a little bit more basic to start with and consider the formulae for the areas of different basic shapes. Let's see what they all have in common, even though they are different from each other. The rectangle is obviously the easiest one, base times height. So what we have is two lengths, which are at right angles to each other, multiplying to give us the area inside the shape. The triangle, slightly more complicated, but it is still a length and another length at right angles, multiplying. Admittedly, we have to multiply by a half as well, but the same basic concept of one dimension multiplied by a perpendicular dimension adapted for that particular special shape makes it an area. The same is true for the circle, a equals pi r squared. There's the radius, but we can also consider a radius just there as well. And so when we're squaring this radius, we're actually multiplying this radius by this radius and then adapting it for the shape, just as we did with that half for the triangle. A equals pi r squared. The trapezium is perhaps a bit more complicated, but the a plus b, notice that they're both inevitably for a trapezium parallel to each other. Let's think about what happens if you add a length like a to a length like b. All that happens is you get a longer length, but it's still a length. So the contents of this bracket are still just a length. And then we multiply that length by the height, which is perpendicular to these lengths. So we still have a dimension multiplied by a perpendicular direction adapted for the particular shape. So in all of these, we have this concept of two dimensions which are perpendicular to each other, multiplying together, and that being us well on the way to working out the area of that shape. Now keep that thought as we think about why you would want to work out the area under a curve. This will immediately feel much more like physics, but maths and physics are indistinguishable at points. Let's consider this velocity time graph. Velocity, speed, not the same things, but for the moment we'll not worry about the difference. The point is they are both, velocity and speed, are both measured in meters per second, and time measured in seconds. And we're talking about why you would want to work out the area under a curve. So let's use what we thought about at the beginning of this video and consider that the area is going to be something to do with this dimension, meters per second, multiplied by something to do with this direction, seconds. Now, you should know how to multiply fractions. Let's see what happens. Meters per second times, now this is a bit like a kind of whole number. We can think of it as being over 1. Meters per second times seconds over 1. These cancel, leaving us with just meters. And we know what meters represents. Meters is very much talking about the distance travelled. And there we have it. This is why you would want to work out the area under a curve. It's because if you have a velocity time graph, the area under the curve describes how far the object has travelled. That immediately makes you think about distance time graphs, which are actually easier than velocity time graphs. Let's think about a distance time graph and see what happens if we do that same concept here. Distance is meters, time is still seconds, the area is going to be this dimension, meters, multiplied by this dimension, seconds, and we get something very strange, meters seconds. Not meters per second, just meters seconds. That doesn't mean anything. And so on a distance time graph, the area under the curve is utterly useless. And if you bother working it out, you're basically telling the reader that you don't know what you're on about. So it's worthwhile just doing this little calculation. If you're faced with a question, you can work out for yourself which one produces the meters, which one tells you about the distance. This is useless, this is really useful. And if these units are describing some other quantities, if they combine in this way, this dimension multiplied by this dimension, if they combine to make something meaningful here, then you can use it in that other context as well. Although at GCSE, it really will just be velocity time graphs and the distance being the area under that velocity time curve.